with our sensors, once you've integrated them into a gripper, that tactile information can be used to tell the gripper how hard to grip. Our sensors basically enable the gripper to pick up anything. So rather than have to program the gripper and say, all right, this is a banana, you can only squeeze the banana this hard, we don't care that it's a banana. We just say, this is where the object is, and then the gripper just figures out how to hold that. That's something that we've been steadfast on from the beginning, because once you try and customize the sensor or the gripper for a particular application, it loses its value almost. So if, for example, you only wanted to pick apples, you could do it with our gripper and it would succeed, but you could do it in one of 10 different ways. And those other 9 methods might be cheaper, might be faster, might be gentler on the apple. But if you wanted a fruit picking robot, agnostic to the type of fruit, that customized design for the apple is not going to work for a peach or a grape. By making it general, it has value. The human finger pad has 2,000 tactile receptors in it. So if that's the goal, we're very, very far from that goal. We have 9, right? So, we want to move closer to that goal of having, a very rich, a lot of spatial resolution, a lot of sensors in the fingertip. But there's still a case of, how do we make the sensor as a whole environmentally compatible? So, if it's going to be used outdoors, you've got UV from the sun. So making sure that all the materials are going to be, robust in UV, making sure that if we're using it in wet environments, what kind of ingress protection is there on the sensor? Is it going to be splash proof or is it going to be submersible? What are we doing there? And that's going to depend on the application.